grown to nearly 16,000 Macs. So, yeah. There we go. Okay. And that's a lot of Macs. Probably some more than most of you have just within the Delta. But I'm here to say that scale can be scary, especially like if you don't have the right processes or tools in place. If you guys were in here earlier, you hear Google with like obscene numbers too. And the way you get there is by spending the time to invest in the right things early on, and hopefully have stuff set up such that you will not be in a position to be concerned with waking up the next morning and having double the size of your fleet. Yeah. Okay, so like I was saying earlier, we have a very unique culture that encourages us to move fast. We have a lot of internal mantras that we live and work by. One of them is, what would you do if you weren't afraid? This one means a lot of different things to different people within the company, but this one to us means that we look at our entire stack of client tools that we use, like, maybe once a year, and ask ourselves, if I had to do it differently, or if all of a sudden, like, I didn't have any legacy stuff, what would I do today? And for us, over, the last few years while I've been doing this, it's meant a few things, and I'm just gonna go over our progression. A long time ago, when I first started, we only had about 1,200, 1,800 Macs at the time, and we were using Casper. And for a long time, it got me very far, and I was the only Mac guy, so it served me well. We did a lot of Bash, and we did a lot of Casper, and it worked. But we started to feel very limited by our Bash code, like the Google guy said, and I'm sure you'll hear throughout some of the other talks. Bash is great for some things and isn't meant for most. So if you're finding yourselves, taking too long, and you start writing functions, and then you start writing like these abstractions on top of everything, then you've probably gone too far. And trust me, I've been there. It's painful, but sometimes it's worth going back and rewriting it in Python. Python's great. Most of my Bash code or scripts were like hundreds of lines, and I could replace it with like a few Python lines. Like, literally, it's so much better. At this point, even Python and Casper felt a little limiting. We started writing a lot of custom code and wrapped it all around the Casper API, and it got us really far. But then there was this one thing here or this one thing there that I just couldn't change. It was built into the product, and you could post on Jamp Nation, but if anyone isn't having your exact issue, or if it's not as prevalent enough, then like you may not get your feature that you need. And this just really hurt us, especially because we look at the rest of our company and they're very big on open source. And up until recently, my team wasn't really, we were using paid products, so it was hard for us to when we couldn't make this individual change. Then recently, not recently, within the last year and a half, 2 years, we basically rewrote everything and started using Monkey, Chef, and Deploy Studio, which isn't up here. And just the amount of people in the community using these products and what you can do with them. There isn't a single facet of any of these tools that you couldn't change on your own if you decided you wanted to. It was very powerful and very liberating. And something that we really liked about Chef and Monkey that we couldn't say about some of the other tools we were using was that we had the ability to use source control and configuration, source control and peer-reviewed changes such that no one person can make a change and smash somebody else's changes without it, being at least looked at by someone else. And then so during the last year, we moved to Chef, and my team absolutely loves Chef. There's just nothing we can't do. And then so why Chef? I'm sure you probably haven't heard of Chef other than probably us talking about it. But we'll go into it. At Facebook, we're obviously a software company. We like to write code. We're very all about open source, and one of Chef's mantras, and in a lot of the marketing that they use, is infrastructure as code. And this really resonated with us. We don't have a red poster for this one, but we have a sticker that we put around a lot, which is code wins arguments. And when we were doing the eval the way we normally do once a year, we evaluated Puppet and Chef and a few others, and we're a little biased. Our production team did use Chef, so it was an obvious answer for some reasons because we already have some Chef knowledge internally. But we also just thought that the DSL, which is just basically true Ruby, made a little bit more sense to us. We were able to spin it up a little faster. So during our code wins arguments challenge, and we started to play with Puppet and Chef, we decided to go with the Chef route because it just made more sense to us. Cool. And then so the next one was transparency. We were able to get this with Monkey as well, but every single change that we do, we use the same production Git repositories that everyone else uses. So when the engineer is complaining about some change that's getting made, he can actually go look at exactly the change we made and often give us a pull request and rewrite it to do something better. But it gives us the ability to broadcast the changes that we're making, and for the people that care can monitor what's going on and offer their own suggestions or help out. Recently, this was a huge win for us because we started to manage the Linux machines in our environment, and my team didn't have as strong as a Linux background as OS X and Windows. We opened it up to our community, and our engineers decided that they wanted to contribute, which meant they basically wrote 70% of the code to manage our laptops, Linux laptops in our fleet. We helped, we did all the peer review, we made sure that this is something we wanted to support, but it was amazing to have everyone kind of chip in. Deterministic. So this is something that I think is one of Chef's really big, strong use cases, is with some other tools, when you go to run a run, let's pretend there's 10 steps. If it fails on 4, it will continue to keep running. Regardless of whether or not they were dependent on it, unless you specified in each of the code that it needed to go. Whereas with Chef, if it comes and it stops and it fatals on 4, it will not continue. And this is really good because it means it doesn't matter what Chef run is running, whether it be a successful one or one that failed out, you know the exact state of that machine, and it didn't try to proceed and configure more things that you may have to go back and fix manually later or whatever. Idempotent. This is a term that's used frequently with configuration management tools, but basically it means it's not going to come by and manage something that it doesn't need to. It looks at the state of the system before deciding whether or not to make changes. Client-side computation. So we do use the Chef server, and the client, when it talks to the server, basically does all the hard work. It's getting its instructions from the server, and we'll go into it further, but basically the client is doing all the heavy lifting, and it means that it's very scalable. Our productions team, when they were messing around with Chef and they were doing their eval a while ago, they were able to mess around and get 40,000 nodes checking into one Chef server. I don't even have that scale today, but it's amazing to think that you would be able to manage that kind of fleet with one server. It's extremely flexible, and we'll get into this a little bit when we get a little further, but it's just Ruby. If you would decide you want to open up a class and rewrite it, or just open up a class and only rewrite one function, you can. It's built into the tool. So what do we want from a tool? This is a whole bunch of just checkboxes. We've talked about some of them. We wanted it to work with the source control product like Git, Mercurial, SVN, mostly Git, And then code linters, we just wanted that to be available to us. We use Robocop and Food Critic, which is a Chef-specific linter. And it really helps with legibility and making sure that everyone is doing things that are sane. And then it works with Fabricator because it is just source control. Splunk. It slurps up all the chef logs, and it's really easy to digest, so we can kind of understand what's going on in our fleet. Then we built a monitoring and IRC like plugins to it, and then coding practices. We wanted to be able to say that we could use this with our tool, which is like we wanted to build our own abstractions and not have to, do the exact same lines over and over. We wanted a central code base, but which same thing. Shards. I open sourced our code for that. We'll get to that later, but shards specifically, basically it takes the serial number of your machine. It is very similar to their experiments, except you can't opt out. Basically, you take the serial, take a hash, and then turn that into MD5, and then turn that into an integer, and then get the modulus of however many pieces you want. So if you wanted to you go out to 1%, you could, or 10%, or whichever, and it's actually very trivial. And then, so how Chef works. I definitely would suggest that you watch this video, but I'm just going to kind of give you a brief synopsis. It's chef.io/chef. So basically, Chef works like this. There's a server, and all of these are your nodes. When you upload code to your server, you'll use something called knife, based on their instructions. We use something called grocery delivery. There's a lot of food references, so just... and grocery delivery is an agent that runs on all of your Chef servers. And basically just doing a get pull. And anytime it sees that there's a change, it does the knife upload on your behalf. And that ensures that no one's like making multiple changes and everything. No one has direct access to our Chef servers. All you're doing is checking into Git. And then grocery delivery handles applying those changes to your Chef servers. Okay, so now Chef has all the cool code I just wrote. It's blue. And the next time any of our clients check in, they're going to download the new hotness and apply the changes that need to be made on their system only. And this is really nice, like I was saying, in terms of scaling, because basically as your client infrastructure grows, or as your server infrastructure grows, so does your management system, because they're doing all the heavy lifting. And then anatomy of a Chef run. So you're not going to read this because it's too small, but we are going to go over it real quick. That's a link if you decide you want to actually look into it, but let's just look at the picture. So, cool. So basically, Chef servers, or the Chef client's going to run. It's going to build a node object with something called OHI. It's very similar to Puppet's Factor, or if you want to make the analogy, Jamf's extension attributes. Basically, this is a place where it's going to gather a bunch of data about the machine that it's running on, and it also gives you the potential of writing your own custom OHI. So cool. It builds the node object, and then it's going to register with the Chef server. It's going to authenticate the node, make sure that it can talk back and forth from then on. It's going to synchronize the cookbooks, basically download all of the cool code, the blue blocks. And then when we get here, this is when it's actually doing stuff. It's loading all of the code that was in the cookbooks in this order, which is libraries, providers, resources, attributes, definitions, and recipes. There's a lot of information here, so I don't expect anyone to remember this. We are going to go over the or the attributes and the recipes today, and if we have time, we'll go over providers. But so yeah, once it does that, it's going to converge. So in this last step, you can think of it as just validating that the system is in the configuration that you wanted it to be in. But for whatever reason, if it's not, it'll go through the converge stage where it's actually going to apply all the changes. And then it's going to run your notification handlers. So when Chef's done, it takes the node object and then shoves it back up to the server. We don't use that portion of Chef. You can. We built our own handlers, and it goes to some of our own internal tools. They have their own metrics and everything around it, and it's pretty good, but we just don't use it. Cool, so next. This is kind of my full disclosure slide. When we first started using it, it was not all sunshine and rainbows. When you go to learnchef.io, which I encourage all of you guys to do, it doesn't even reference OS 10. But if you give it a little bit more of a chance and you kind of really dig into it, I chose the Red Hat, documentation I was going to learn, and it gives you some examples, and you can start to look at it. And yeah, it's server specific. You're not going to. Well, maybe I guess you could manage the message of the day on your systems, but you're probably not going to. It is managing a file, which we all do when you think about it. Oops, sorry. Okay, we all do manage files when you think about it. And we're going to go over this a little bit in detail, but if you just stick with their documentation, you can start to apply some of the things that they're talking about with servers to your client infrastructure. Just in your own head, do the change every time they mention node as server, just think client. And this is an example of it actually making that apply, but we're gonna dig into that later. Cool. So during the learnchef.io, you will actually see that they have a development kit, and you can think of this as like the Casper suite, or like all the tools in Casper admin that you use to manage that system. When you download it, you're going to get a few tools. One of them is the Chef client, sort of like the Jamf binary, and then you're going to get Chef, which is very much like, I guess you can say it's Composer. Because what it does is you can say chef generate cookbook, and it'll make all of the boiler template code for you, and we'll go over that a little bit. And yeah, so definitely give it a shot. But at this point, you're noticing, hey, it does support OS 10. And then you go a little further. When I first started using it, it didn't do service. Their service provider, which basically means launch CTL for them, did not manage launch agents. We checked in a pull request, and we got launch agents functionality, and by default, it'll launch the launch agent as that user. So yeah, like I said, this change was fairly trivial. It took longer to write the tests that they wanted me to publish to push the change than actually the code itself, and it wasn't that bad at all. So cool. Demo time. I'm going to do something a little different than like I've seen other people do. So first, we're just warning, I'm going to do it live, and there might be problems, but we'll see how it goes. Also, we're going to go over, basically my goal is to have you install Chef at some point. You don't have to be now, and then be able to at least manage a file and a service. But we're going to go as far as doing Monkey as well. So cool. Yeah, let's do. Cool. All right. So the example that we showed earlier was laying down a file. Well, here, let's do this first. So cool. Not that. What? It's just annoying. Exactly why you shouldn't do live demos. Okay, all right. So this is my Chef repo, and inside my Chef repo, it looks like this, which is some cookbooks, nodes, and roles. And remember how I was saying that you can just do like Chef generate repo? Like it would make all of this for you. It does all the basic directories and stuff. I've cleaned it up because we only care about this today. Inside my cookbooks, this is kind of what it looks like. Each of these are changes or like organizational units around certain configurations that I'm going to be making. These are the examples we're going to go over. And inside of the examples cookbook, there is a recipes directory. We'll go over some of those. An attributes directory, which contains essentially an appended item for the node object. So remember earlier when I was saying when you run ohi in the very beginning of Chef, it's going to give you this whole nice node object that you can reference. But in my attributes, I can add something to it. So you can imagine that it would be something like node.firewall, and it would say true or false, like it's enabled or not. But in addition to that, in each of your cookbooks, you can say, hey, by the way, I want you to to the default node object, I want you to add a dictionary of example with a key value pair of name and Mike Dodge. And then again, example, username, M Dodge. And we'll show you where we're getting into that right now. But this is a chef recipe. If you look at it, it's definitely in code, it's Ruby, but it's also fairly legible and fairly English-like in my opinion. The first thing that it's showing you is right here, and on line 5, it's saying log, what is it logging? Welcome to chef, and then it's a variable that it's calling, which is on the node object, example name. So we know what that was because we just saw it. It's going to say Mike Dodge. And again, it's going to log of a level, which just means like what type of log is it's going to be logging to. Then on 9, we're saying username equals node example username. Now, this is not how I would do this in my own environment, because like you could just shell out and have that return as username, or I think Ojai actually has a built-in user, but I wanted to give you guys show you how it's done. So then, yeah, and then now we're going to manage a file. Which file? Users, username, desktop, chef test.txt. What is that file going to contain? Hello world. It's going to have the owner of username, which we've already defined, and this is going to be the mode. So that's pretty easy. I didn't have to say, this is how you create a file. I didn't tell it how to create a file. It just knows. It knows that it needs to be a file in that location. It has to have that content and that stuff, but it's all very like just there. Let's see how that works. All right, cool. So, remember earlier I was saying how you can just call the chef client, which is essentially a chef run. Typically there's a configuration on disk that tells it to talk to a server, but we're doing a local run, which is why we're using -z. It means we're going to run it locally. And basically what that means is the machine itself is going to spin up its own like little mini chef server. And then it, as its node, is going to talk to itself as a server and then run. So in a VM, it can take a little while, but I've pre-cached some stuff, so it'll go quickly. And then we're telling it to override the default run list that would normally be defined on disk with example. Because we're already in the cookbooks directory, it knows that example is a cookbook, and it knows how to find it. But we're not going to run the entire cookbook, we just want to run the first recipe, which was the one we just showed you that's going to do this stuff. So cool, we come back, we hit run. Right now it's building the node object, it's getting a bunch of information about the machine. It would start synchronizing the cookbook from the server, but I've already cheated and put those in there. It's giving you some warnings because Chef isn't actually configured in this VM. We're just running a very lightweight instance of it. At this point, it knows about the cookbook, cool, and it also knows about the attributes that we appended to the node object. So right here, when it does actually get to the point where it's going to log, it's saying log, welcome to chef, Mike Dodge. And then here, it noticed that the file was not there. So it's going to take the action of create, because that's the default action of the file resource, which, just so we're getting the terms right, each block of chef code is considered a resource. Cool. All right, so the file resource knows to manage this file, and it's going to create it because it wasn't created. And then it notices, oh, by the way, it didn't have the correct content. So it's going to update the content of that file, and here's the diff. Basically, it had nothing, and it's adding hello world. Cool. Now it's validating that it's going to have the right permissions. It didn't, so it's applying those. And then the same thing with the username. Now, that's cool and all. Cool. But what happens if you run it again, right? I promise you it would do nothing. So basically, we'll see that, but it's going to spit out a little bit of just, hey, by the way, it's good state. And we'll see that right now. Shit. All right. And okay, cool, there we go. And so it did log because we told it to log every time, but look at the file it skipped that entire resource altogether because that file already contained the right information. But what if it didn't? And what do we call it? Show test. Actually, let's cat it for, well, whatever. Bim. Cool. So yeah, it does exist and it contains hello world. But what if some rogue user said, bye world? It's very, very cynical. All right. So we save it. It's cleared out. Cool. Now let's run it again. And again, we're just running the same example. Cool. And just to give you a sense of like how much slower it is in a VM versus on our own machines, we typically manage 800 things, and I know that sounds like a lot, but a lot of them are just files and stuff like that. And in our run only takes about 30 seconds. So like this is considerably longer in a VM and with Chef Zero. But okay, so cool. So it logged again because we told it to, and here's the file. It noticed that it needs to update the content because it didn't match, and it said it was by world, but you guys can see that, yeah. And instead it changed it to hello world. When you boil down most of there we go. Okay. So, what was I saying? Oh yeah. So now we're managing these files, and when you boil down all of our configuration and most of our day-to-day jobs, half of the time it's just basically managing one file here, managing one file there. So just with what I've showed you so far, you can get actually pretty far with what you're probably doing with some of your tools already. Okay, so now let's look at something a little bit more advanced and some more of the power of Chef. When you look at some of the other tools that I've seen, you're limited by whatever they happen to build within their DSL. I'm saying that right, yeah. But with Chef, it is just Ruby primarily. So if you don't like anything, you can just change it. But also within the Chef code itself, you can do some really cool stuff. So like on line 9, here's me creating an array of 3 directories, which are just recursively deeper. There's a way to do this recursively, but actually I just wanted to show you, like, I can use an array in a cookbook. But here's these three directories. If I decided to make one more, I would just obviously add one more to the array. We're iterating over that array with a dot each. And we're defining each iteration's variable as dir. And we're passing that to the directory resource. So now it's saying directory we're going to manage is library CPE. What are we going to do? We're going to make sure that it has a mode of 755 and the owners are root and will. And it's going to do that for each of those. So cool. Now you can kind of get an idea of what that layout is. Next, what are we going to do? We are going to manage a script, which is called launch daemon init. And we're going to, and this one's a little different because remember earlier we said file. This is actually not a file, it's a cookbook file. And remember when we were talking about like the directory structure of a cookbook, you can include a directory called files. So this cookbook, when you call cookbook files, is referencing any files that you packaged up along with the cookbook. And in this case, in its default directory, we're bringing a bunch of stuff with us. But the one that we're actually showing you is this script. What are we doing with it? So we're taking the script that is shipped with Chef in the cookbook, and we're putting it on disk in that location as that name, and this is the source file that we're telling to put it there. So put this file on disk in this location with a mode of 444, okay, and owner, root, and will. And then we're defining a launch daemon path only because I didn't want to have to like write this out a bunch of times. And then here are a bunch of launch daemons. I'm creating a daily, an every 15, an hourly, and a startup. And each of these daemons I wrote using some other tool. And basically all they're doing is calling that same script over and over again, but passing a parameter. When it calls that script so it can handle it differently. But yeah, these are just plist. We all manage them probably very frequently. Actually, just to prove a bet that I was talking to someone, how many people actually use launch daemons in their environment? Okay, cool. All right, cool. All right. Makes me feel a little bit better. Okay, so yeah, so we all use launch daemons, and it depends on how you put them there, but with Chef, it's going to manage every facet of it. So if someone wanted to come by and change one line or what binary it was going to point to, it's not going to happen. With this, I'm just saying place all these files from the source directory on disk in this location with these permissions, but this is the new line you haven't seen yet. And what it's saying is notify the service of daemon, which is, we'll show you, and start that service or restart that service if it's been changed. So in this case, this is the service provider. It's essentially launch CTL, and it'll tell a given launch daemon label to load, unload, restart, and some basic stuff. We're telling it that this particular case report supports restart, but I don't think you actually need this line. And then action by default, it's going to enable it. So real quick, we're iterating over all of these launch daemon labels. We're putting all the files on disk. And if they change, we're also telling the service provider to restart it. But for whatever reason, if they haven't been changed, but they're not loaded, it's going to make sure that they're enabled. So cool. That sounds like a lot of stuff, but really, like, it's not that much at all. This is hardly any code at all. Okay, so when we come over here, we're going to run clear. Cool. This time we're running example 2. And again, it's building the node object. It's getting to the cookbook and the recipe of the 2 recipe, and it's realizing, oh, all of these files aren't going to be on disk. And now that it understands that, the next step will be converge, and we'll see that. And it'll fly really quickly, but we can go over some of it. And yeah. Oh, so, I mean, it's very similar to what we were already seeing, but like that was it, putting the file, changing all the permissions for each of them, then making sure that they're enabled, but because I told it to restart, it's going to restart just to make sure that it has the latest version. And yeah, so now if we run it again, it should do nothing, which I think is really important as a as a system administrator, right? You don't want code running unnecessarily on machines or changing state when they don't need to be. And this is a really good example of part of the power of most configuration management tools. They'll do this. So again, that's saying it ran, it checked, it said Chef finished running, and it basically did 0 out of 12 things I told it to do, and this is the amount of time. Again, this is slower because we're in a VM, but okay. So now, well, we already showed you that it'll re-enable it if you disable it, but yeah, if you touched any of those files, doesn't matter what you do, unload the launch daemon, change the permissions such it's not going to load whatever executable. People get really creative in my environment. This handles everything. I haven't found any use cases where like it just doesn't work. So cool. We went over attributes. We gave you a couple good, like, very basic recipes, but I'm sure all of you guys can identify with some of the stuff that we're doing at some basic level. Next, let's go back to the slides real quick. Cool. Just annoyed. So Monkey, you heard it from the Google guys. You'll probably hear it a dozen other times throughout the rest of the conference. A lot of people in our environment are using Monkey. It's a really, really good tool, open source, written by Greg Nagel. Monkey, when you boil it down, is essentially an application. This is our version of Managed Software Center. We've done a few customizations. My personal favorite is NanCat. It's animated. You can put animated GIFs in there if you haven't done it already. It's pretty cool. Okay, but anyway, so NanCat. And so application, and then configuring Monkey. Monkey configuration is installing a package, but it's essentially just user local with a bunch of scripts, and there's the applications that we just showed, or the application that is Managed Software Center. It installs a few launch daemons, and it installs a few launch agents, and it requires a reboot by default. That one bit us pretty hard because we just said, oh, well, we know better, and anyway. That being said, now that we manage everything with Chef, and we updated the service provider, it actually handles the launch agents and launch daemons appropriately, such that when it does install all the files on disk, and it in our version installs the package as well, it loads and ensures that the Managed Software Center plist is always loaded so that your users actually get the notification, and it doesn't require a reboot. But let's look at the monkey code. So in our environment, we have very similar to how Google's were saying, but we have a production manifest, and then we have a testing manifest. We have a few like team manifests for reasons, but we actually heavily use monkey conditionals. And so everyone pretty much goes to prod unless there's some exception why you wouldn't. Everyone pretty much goes to like one or some of the same monkey servers unless there's a reason why they need to go to their local one. And we have some code for that. But that's what's kind of cool with Chef is we come by and we dynamically change all these settings based on who's logged into the machine and all this kind of stuff, what manifest they should go to, what servers they should be pointing to. This is a very dumbed down version of that code, but it will get monkey on your system. So when we were showing you the file structure earlier, we were showing you the example one. This is the CPE monkey one. There's a whole bunch of files, and inside there's a directory for launch daemons and launch agents. There's a monkey directory, and then for every version of monkey that we'll want to deploy, we'll have that version number and then all of its contents, and then a monkey path file to get it in the default path. But so we're pushing all those files along with the cookbook, and inside the recipes there's a default recipe, which is what we're looking at. So again, this recipe will push out this version of monkey. The app version of Managed Software Center is this version. We will use that later. Again, this is a very common pattern you've seen. We're just creating a whole bunch of directories. Cool. We're going to do a new one that you guys haven't heard of, which is remote directory, which is essentially the cookbook file to file, or the remote directory to directory, which is, it's just going to take the contents of a directory contained within a cookbook and put it on disk. You can specify all of the permissions, and it's very similar to what we've seen. There's a few other ones you haven't seen, but they're pretty self-explanatory. The one thing that's a little different is we are saying conditionally which version of monkey to install. So you can imagine that in my attributes file, I could say, well, you're in my test piloting group, so you're going to get this version, or you're just special and you get this other version. Those special people. Okay, and then launch daemons. Here's all the launch daemons that they install by default. Let's make this bigger. Yeah, because launch daemons are long. And then again, putting those on disk, making sure they're started. Now, depending on how much time we have left, we'll get into this a little bit. This is an example of us writing a custom resource and provider. Think of the resource as the API that you can use to do a said thing, and then the provider is the actual how-to. This one in particular is called CPE remote, and then we're saying we're going to do a package. We're saying what application are we actually using, and what's the name of the package, what's the version, what's the receipt, and then we do some checksum stuff. And it's going to download this from one of our monkey servers. And then, well, first, before it ever downloads it, it validates whether or not there is a package installed with this receipt and this version. And if not, it just goes out and downloads it from our monkey servers and then installs it. Cool. Then, which you wouldn't need to do, by the way, because monkey can install itself, but whatever. And then, launch agents. These are all the launch agents. We're putting those to disk. The only one that we actually care about loading is the Managed Software Center, because the other ones are just ran at login window or when a file gets touched. But, so again, this is just real Ruby, right? We get to the point where we're saying, drop all these cookbook files on place for each of these. But if there's a launch agent, because that's the one that's getting passed, with the name of Managed Software Center, we're going to notify that service to restart, which is written right here. And we're telling it restart or load. Oh. And then, okay, keep coming. Just a cookbook file for adding, the paths for monkey. Cool. Oh, this is cool. So remember, we're talking about the OHI attributes. We have a custom OHI plugin that will alert Chef to whether or not this is the first run of Chef, whether or not it's just been imaged or whatever. So now, only if, and usually I'd remove this comment, but only if it's the first boot will it actually touch the check and install startup flag. So we image a machine, we install Chef, we run Chef. Before the user ever has to log in, Monkey's going to load and install all of its stuff. Cool. So again, we dynamically generate which repo they're going to go on based on their region, but just defining this, cool. Now this is going to be a whole bunch of key value pairs for the managed installs plist, and we're saying there's going to be a key of software repo, and it needs to have the value of monkey repo, and it's a type string. And then we do this over and over for each of the things that you would manage inside that file. And then again, we're iterating over each of those dictionaries in that array and running the Mac OS X user defaults. This is a third-party open source LWRP, which is like the resource that you can put up in Chef's supermarket, which is essentially their extension on GitHub that will allow you to just go check out what other people have done for OS X. There's quite a bit there. This one's pretty useful. It's essentially just doing a defaults write and read, or just write, but yeah. And then in this case, we're telling it to do Mac OS X user defaults, and then this is just a string that's going to be applied to the log setting value for, and then cool. Which domain? We define that. Domain is the plist. Cool. Which key? We have those keys up there, and then the value and the type. So now, you've basically seen the basic pattern that we use for a lot of random stuff, and this is actually very, very simple. You can do way more complex stuff if you need to, but quite often, like, managing stuff can be this easy. We're just explaining to Chef what the system should look like. So real quickly, let's run that one. So we're gonna go CPE_monkey, cool. Now we're going to run. So again, this should take a little while, but we cached it, so it shouldn't be that bad. And this is going to apply every script that Monkey uses, every launch daemon, every launch agent, and make sure they're loaded. And once it gets going, yeah, it looks really fast. Cool. So yeah, that's it. It did 86 things in 22 seconds, and now this machine has Monkey installed and would start reporting back in to the Monkey server that, in this case, doesn't exist. But what's really cool is, imagine like anyone that got really creative and decided to open up a Monkey script and change what it did, or decided to delete user local, or whichever. Chef will come by and make sure Monkey is in the exact state that you told it should be in, and then it's very helpful, especially if you want to do your own internal customizations to Monkey before you're ready to do a pull request up, but you just want to change something real small for your environment. It's been very, very helpful. So again, we'll just run it one more time so you'll see that nothing's going to happen. Cool. And I wanted to talk a little bit about what you're seeing. So when Chef is running, it's running something called the Chef. Yeah, it's called a Chef formatter, and the actual, well, that was quick. It validated that 74 things were done in 14 seconds. Anyway, so the output that you're seeing is actually just a Ruby class that you can overwrite, and there's plenty of like third-party versions out there. Let's go to. So let's actually just show you what I mean. So like you can customize all the things, right? Including the Chef handlers, including to an obscene amount where you would probably never want to do, including Nancat. So like your Chef formatter as it's running can like actually just print out in Nancat. And you're seeing that like, yeah, it's finding that we're gonna be updating about 800 things, and each time it updates it, there's a little plus that goes by. And because your manager asks you to make your output look like Nancat, or whatever it is that you need, like whether or not it be your logo or whatever thing that you're doing, you can completely customize any facet of Chef, which is part of the reason why we really like it. So next, takeaways for us. The learning curve can be steep, but it's worth it. Just like hang in there. Definitely check out the learn.chef.io. Automate today what you don't want to have to do tomorrow. For us, like most of the time, it was just we found ourselves having to validate whether or not our systems were in a given state with other tools, and now we just don't have to do that. Very customizable, very scalable. Reuse and share. It just gives you one more opportunity to like write a cookbook and put it up on the supermarket or GitHub or wherever. And we plan on open sourcing a lot of our stuff. When we wrote all of our code, it basically took us 2 months to port everything over. So we, wrote it with very like us in mind, but we are going to go back and like spend the time to make everything more generalized, and that should be coming very soon. And then basically stop scripting and start coding. You've heard it from some of the other guys, like Bash is only going to get you so far. Start looking into like an object-oriented language like Puppet or Ruby. I actually feel like if you're just doing generic things, they're very similar. Every language has its little quirks, but the more you code in different languages, the easier they all become. So just keep pushing yourself. And then ask yourself what you wouldn't do what would you do if you weren't afraid, right? Like some of your tools might work for you now, but will they scale? And maybe you can head that off, before the pass. So this is just a random slide with links. I actually have a lot more time left, so I'm actually gonna like open up to questions, but also if you guys wanted to see anything that I didn't cover, let's see if I can do it live. So let me know. But yeah. Thanks. Any questions, or you want to see me try to do anything? What? Yeah.
So during the chef run, when something was changed, it spat out a little number, which I believe you said was the diff number?
The diff or the hash of the file that changed. But let's do...
I think it was only when something was changed.
Yeah. So up here, well, yeah, right here. That's like the file, time, and stuff like that.
E5.
Yeah, it does look. It looks at the hash on disk.
Okay.
And that's how it determines whether or not it will show.
You can look that up somewhere and see like.
Well, you can look up the file hash on disk, and then it knows its file hash already because it has the file. So it has the hash of the file inside of the cookbook. So like if I tell it to say, hey, the file on disk needs to be this, then it knows the hash of that file, and then it can manage or just look at the hash on disk, and if it differs, then make the change. So yeah, cool. Any other questions? Yeah.
It seems that you're using Chef to install and configure Monkey.
Yep.
How do you deliver Chef onto the systems?
Okay.
I guess I'm curious, what is your workflow like?
So he noticed that we use Chef to install Monkey. So what install Chef? Cool. During imaging, we install. So our imaging workflow is Deploy Studio, and basically it does nothing. It just drops down the OS or not, depending, and then it installs Chef. It does some cool stuff where it also injects all the Monkey cache already. Cool. And then in its second Deploy Studio environment, it runs one Chef run that configures Monkey and everything else, and then keeps going.
And the actual Chef software, is it like a agent node, kind of like comparable to Puppet?
So, and what is the Chef agent? So the Chef agent is just one package that you're going to install called their Omnibus. It includes everything, including its own version of Ruby and all of its dependencies all in one directory that no one is probably going to mess with because it's off to its own. And yes, so in some way, I guess it's similar to Puppet in that regard.
Yeah, that was my last question. If you look at Puppet, and would you able to join in parallels or compare or contrast?
In our testing and from anecdotal feedback that we heard from others, when using the Puppet server, it's not it won't scale as well as our Chef instance.
Got it. Yeah. Something I looked at for Puppet as well. You can do a setup without a server centralized, like a peer-to-peer.
Yeah. We really like the way Chef is designed and how all the computation is done on the client side, and it still allows us to have a server, which is currently what we want. But yeah. Any other questions, or is there anything else that you guys want to see? Back there, do you mind going to the mic? Sorry. And then Wes, what?
The launch agent part that you mentioned, that's been merged, right?
Yeah, that's in the latest, as of 12.3, and I think they're on like 12.4. Oh, and that's something I didn't mention. Chef, there is no paid version, there is no open source version, it's just open source. If you want support, you can pay for support.
Well, that's actually part of my question is when you look at the Chef website, it says that the standard version is limited, the management console is limited to 25 connected. How does that work with, you can have up to 10,000 nodes, but you can only manage 25 of them?
So, the Chef server is essentially like MacAdmin or JSS in a lot of ways, and you can do, like, you can update a single node, you can do, real granular things on the server. I haven't used it personally. We end up just checking everything into Git and having grocery delivery just manage all the changes. I thought that the latest version of the Chef server is completely open source. If it's not, we can check.
I just got it off the website.
Okay, cool.
That's why I was...
Yeah. I don't think you actually need it, realistically. If you decided you wanted to use it, I think their support's actually really good, and you get the support with the server. Even though we pay for support, we don't actually use the server. Or not the server for that capacity. We don't use the web UI at all. And I think there's a lot of benefits to not using the UI.
The web UI.
Yeah.
Okay, thank you.
Hey there.
So at this scale, how do you test all this stuff?
So I talked about that in another talk, and we glossed over it a little bit. I can reference some of the code, but it is up here at our GitHub link. Well, it's it-cpe. There's a Python module up there that is called like sys_tools, and we use something called sharding. And in a lot of our code, at the very top level of a recipe, we can just say return unless, which is weird Rubyism, but basically it's like an if not, and then shard, and we give it a number. So we can say a shard, and we usually do 10% blocks. So we can say if you're not in the 10% block, which is the modulus of essentially the serial number, then don't install. So we can gate changes to shards, and they slowly roll out because we're doing a range. So eventually it'll be like 5, which is like 0 to 50%, then 100. So that's great for like, okay, we're ready to go to prod. But if I wanted to give someone a select change, we actually do it very similarly for both Monkey and Chef, and we use Facebook group membership to scope things. But you could replace that with AD group membership pretty easily. You know the user on disk, and if you have a reference to some place, you can look that up. So you're just saying, hey, this user is Mike Dodge, what group memberships is he in? Cool. I'm only scoping to this group. Is he in that group? No, then keep going. And writing the abstraction for that within Chef was very easy. We didn't get into libraries today, but every cookbook has the ability to just load additional Ruby code, and you can just give very simple things like is in shard or is in group of, and then you give it the group. So it's pretty useful in that regard. And I eventually want to open source a lot more of our stuff, but some of that kind of like, we're doing Facebook group membership. I'm not convinced that's going to be very helpful for anyone else than us. Yeah.
Cool. Thanks.
So how do you guys deal with network storage for your users? I know, with the decline of OS X server and X server.
So how do we manage users' data, or our Facebook employees' data while they're on their laptops? We don't. Like, they have Dropbox. If they want to use it, they can use Dropbox. Like, we don't do any backups or anything like that. Most of our stuff is in the cloud, and if it's not, it's using Dropbox. Cool. Any like Chef things that you're thinking of, like, hey, how do you manage X? I can probably do it live. Oh, Flash. Okay, cool. So that's a good example. Binaries. We do all of our Chef binaries with a custom resource provider that we did to do packages, which we talked about a little bit, and I can go over if people are interested. But primarily, any updates are getting done through Monkey, especially if the actual software that's getting applied, it has a graphical user interface, because I wouldn't want to come by and smash something if they were using it like other people were saying. So yeah, if we want, we can go over the package provider that we wrote. So let's go. Cool. So cool. Oh, we didn't go over. Yeah. So actually, before we do that, Chef is designed such that you give all your clients a run list. And your run list is usually defined on disk or on the Chef server. Our run list is very small because it's dynamic and it's generated on the fly. So the first thing it does is it ensures that it's configuring itself. Then it's going to ensure that the service for itself is running. Okay. Then it's going, and because we run our Chef instance on Windows, Linux, and Mac, it's going to run its corresponding platform family underscore init, and in this case, Mac OS X init. Then it's essentially just building an array of cookbooks that it should run. So if the node is in first boot, it's going to do some first booty stuff in AD. If it's any other run, it's going to randomize our local admin password. It's going to configure like our AD stuff. It's going to install and manage OS query. It's going to like manage some password WD stuff. It's going to manage a screensaver, all this stuff. And then we'll get to like some custom stuff we wrote. If it's a laptop, do X. If it's a desktop, do Y. At the very end, we're just going to log out the fact that we did some of that, and then we're going to use the run list to iterate the array that we just created and include each of those recipes, and it'll off to the races. It will do all those settings. But we're essentially managing this one array, and we can do all the scoping and everything within here. Cool. So resources and providers, there's like talks dedicated to this, but if we're just going to dig into it real quick, it's basically two parts. The resource, the actual like API that someone will use, and the how-to, which is the provider. So this is us describing what this LWRP or the resource has options to do. It's an app. It has a checksum as a value. It knows whether or not it should clean up after itself, whether or not it's already installed, what's the package name, receipt, whether or not it needs to go off and download it, and what version. Cool. Then we come over to the like actually how-to. When it gets into here, we're including shell out because we're going to be doing some bash commands. And then every default provider first does load current resource. It's going to initiate an instance of this class, which you just name. And then that's actually referencing the resource, so it knows now it's bringing that object over and giving you all of the like .cleanup, .appname, .version, and it's all on that object of package. We're defining the package app, which is just like the name we use. We're doing some logging. Cool. Now we're running a function called installed. Like, is it installed? We come down here. Basically, we're just looking at we're getting the package receipt. We're doing a shell out with the packet, running a bash command of package util dash packages and getting the receipt. And if the exit status is 0, that means it's installed, and it proceeds. Otherwise, it would have returned false, and then it would go install. But okay, we know the package is installed, or with that receipt, but doesn't have the right version, right? So this is the command we're going to run next, which is package util dash package info, and then here's the receipt. And we're going to do a shell out of that command, and we're asking ourselves, does it include, and like it's just basically a grep, a version and then that version number? Because if it does, or if it doesn't, we're going to actually go off and run and install it. But if it does, then we just return true. And yeah, we're giving a message to the user. This is already installed, but if you want to remove it, run sudo package you get, forget. Cool. Then when we get to the actual install portion, because if it needs to be installed, it's only going to run unless the package is installed, meaning if not package is installed, which I have to do in my head every time because unless kind of messes me up. Okay, so then just getting the package name, and we have a format which is package name dash version number .pkg, and this is the default cache path that Chef uses. Cool. This is the file that we're now downloading. We know it's going to be this package name with this version and .package. Cool. This is the download path. Or this is where it's going to download that file to, sorry. Cool. Then if the file is remote, which at this point we're going to say it is, it's going to generate a URL, which just imagine like this is your one monkey server or your monkey servers, and you're telling it, hey, give me a server URL. This is the package name directory that I'm going to download. This is the actual file that I'm going to download. And it's just using the remote file resource. So it's going to say, hey, use a remote file, but instead of looking for it in my cookbook directory, go reach out to the server, download that file, and place it on disk here. Cool. Once that's done, it's just validating some of the names that we already have. And then this is just a straight up like bash execution block. And it's doing some logging, which it's just saying what the checksums are on disk, so that it says if the new resource, like the checksum that we provided, does not equal the checksum of the file that we downloaded, meaning like we got man in the middle or somebody screwed up, exit. Otherwise, we're going to run, which is just run this installer, and then we're going to manage the fact that we're going to delete that package, but only if we told it to. And so yeah, that was a lot. But realistically, it actually wasn't that much code to write, and it only took me like a couple hours. So when we manage packages, we actually run it with our own resource and provider, and we download it from our Monkey servers for anything that doesn't have a UI. Other than that, Monkey uses it. Monkey actually manages it. Cool. Any other questions?
You mentioned the Chef has an executable which collects information about the node itself.
Yep.
Like,
hi, or factor.
exactly.
Yep.
Would you demonstrate that part?
Sure.
Which attributes is it for?
Yeah, let's do it in the VM first. So if we would just run, hold on, it's running Monkey. Yeah. But as an example, this is a OHI plugin that I added that's custom. And basically, it's just some Ruby code. There's some boiler template stuff that you can look at on Chef, the docs.chef.io. And if you go there, it's going to show you some boiler template. And I just wrap some bash commands with some Ruby to get me some data. Like FDE setup is active, and it'll return, I believe, a Boolean, true or false. And then FDE setup has recovery key, or institutional recovery key. And then it will return a value, and then I'm populating a new dictionary of file vault encrypted, like, you know, and then if it has value, it's true, or it's going to be, or it's not going to be true. Sorry, is file vault encrypted? And then it says, in this particular case, it's saying, what is the value? Does file vault status equal true, return true, or false? That one's weird because it probably is lowercase true and not an actual Boolean, because it's a string that bash returns. So that's what that's good doing. But anyway, let's look at this. So we said, what does it look like? What are some of the default stuff? There needs to be more. We wrote a lot, but it does give you a lot of stuff. Just stuff that like maybe a MacAdmin might not necessarily think is useful. There's a lot. There's a lot. Like all the users on that machine. Well, let's get to the top.
This is the one you customized?
No, this is the default one. This is they give you a lot, like everything you can probably want. But some of the stuff that, like, as MacAdmins, I don't think there's additional things that we can add. We basically dumped a lot of stuff from System Profiler that we cared about into here as well. But like, yeah, here's everything about CPU, and then like, okay, let's keep going. Whoa. Now here's everything about the file system. Yeah. Shares, where it's mounted, kernels. Yeah, kernel stuff. Oof. Yeah. So there's quite a bit, but it's actually really easy to extend, and that's probably like the thing I'd really take away from OHI. It's really easy. So yeah, network interfaces. Cool. And then it's as easy as like just adding something into the attributes file of a given cookbook to say default, and then whatever key, and then whatever value you want, and then it'll just append to the node object, and then you should be able to use that through the rest of your cookbooks. Cool. Any other questions? Yeah?
Hi, with 16,000 Macs, what's your monkey organization like? Like, how do you break that down in monkey?
Okay. So do you mean by manifests?
Well, yeah. Is it just one giant
Okay.
open catalog that people go into to get what they want?
So we essentially have like four manifests, but realistically we only pretty much use two. Well, three. We have one for our team, and we push everything to our team. We encourage whoever's doing the stuff to load it on their machine, and then we won't push anything out to our fleet unless it's ran on our machine. So cool, it goes on our machines. Then it goes to trusted testers, which is pretty cool. It's like a group of like 600 or 700 people that all decided that they wanted to be opt-in, mostly because they didn't want us messing with their system, but it meant that they got heads up and understood what was going on, because every time we decide to push a change, it goes to trusted testers first, and we post in this Facebook group, hey, by the way, this change is coming to you, and they give us feedback or whatever, or they're like, oh no, it broke everything. I'm like, okay. But quite often they're also monitoring some of our diffs, so like, sometimes they'll contribute and stuff like that. But anyway, about 600 people, cool, goes to there. Then, depending on how we feel there's a risk or not, it'll just go to production, or like everyone. But typically, if it's like there might be some concern that it's not going to work, we'll use a sharded rollout, which is not an additional manifest. It's just a monkey conditional on top of that one package info within the catalog, or yeah, I'm saying that right, catalog. So the machine is reporting what shard it's in, and we're saying that this particular package will only go to shard X. And then we'll add
like
a shard.
Staged rollout.
Yeah, staged rollout like that. And our shard code is actually very, very simple. It's you can look it up on our GitHub. But yeah, we use a monkey conditionals a lot because we like to scope things to Facebook groups. But you could use AD groups or some other opt-in mechanism that you can think of. And as a good example, 1011, we already have a beta group, and it's currently like at 30 people like that we've let like install it, pretty much went and installed it on their own. But we plan on opening it up to our beta group, and only by just saying, hey, by the way, as a managed software center optional install, scope it to anyone that's in this beta 1011 group. It's probably about 300 people right now, and we'll probably do it very soon because like it's fairly stable. So now we'll have like all this extra feedback, and by the time it comes to a release, hopefully we'll have reported all of our bugs to Apple and stuff like that, and it'll be fine. But like that's a good example of what we're doing. And we're not doing it with multiple manifests, we're doing it with monkey conditionals.
And you have mostly managed installs or mostly optional, or is it?
Ooh, that's a good question. We have tons of optional installs. Like if you saw, it's not gonna load, but if you saw the picture, it was, we had a bunch in there. We basically let anyone install whatever they want, in addition to the things that we manage. The things that we manage are anything that has a security update and that we're concerned about. So like all browsers are managed installs, but we don't do it until like a couple weeks after or like whenever we get to it, which is like a week or whatever, because the browsers are iterating pretty quickly, and usually they're already updated. But for whatever reason, if they're not, they're going to get managed. And the way we've done it is with our users, we've made an agreement with them that we're only going to that we're only going to prompt on Wednesdays. So we wrote some logic around the pre-flight and post-flight to ensure that it's only going to prompt on Wednesdays between 12 and 5 with a normal monkey prompt. And then if it's not that day, it's going to throw a terminal notifier instead, because we believe that's less intrusive. And you can use the tool to disable it. Yeah.
Oh, cool.
Yeah.
Thank you.
Yeah, no problem.
What's the size of your team that touches monkey and chef?
Ooh, good question. So we just split it up because like we're starting to have problems. We were a team of three, so 6, and just recently we got one more, and then one more, so 8. But then we broke it up. It's CPE build and CPE ops. The build guys are me and Nate, and we're working on things that should impact us 6 months to a year from now. Like we're trying to like do the new things. Day-to-day maintenance stuff is just the 6 people, 3 Windows, 3 Mac. Yeah.
So your users have admin rights?
All of my admins have admin rights. Well, no, that's not true. Just as of like a couple weeks ago, we decided our culinary staff, who all have laptops, probably don't need admin rights. So realistically, we're managing everything like for them with managed software center and stuff. So we removed it from them, and we're looking at like other ways and like other portions of our population that like would not be hindered by removing their admin rights, and we're doing that. But in general, like, yeah, everyone has admin rights because it's really hard to manage like every possible like way an engineer could potentially do it, like, or would want admin rights for. But at some point, like, we will probably get to a place where we come up with a creative way to optionally give them access without being too much of a hindrance. Any other questions? Anything else you want to see with Chef? No. Well, check out those stuff. Yeah, we'll answer your question. If you haven't already joined this Facebook group or the IT think tank, definitely do that. There's a lot of good stuff in there. Yes, we use Windows machines. Our population, I don't remember this number. It's like it's not that our Windows population is shrinking. It's just not growing nearly as fast as our Mac population. And I want to say we're approaching like 90-10, but it's probably like 80 in the 80s Mac, then like the rest PC, and then like we have a couple hundred Linux users. But I'm assuming now that we're officially managing Linux, that population may grow. And so to extend that, we're using Chef to manage our Windows machines now. We use Chef to manage OS X, Windows, and Linux, and we use Monkey on Macs to deploy packages, and Chocolatey to deploy packages on Windows. Yeah, it's pretty good. You should check it out. And Chocolate and Nougaty. Nougaty.
Nougat.
Yeah, people like food references. I like food references. All right. Any other questions? Well, if you think of anything else, like, come, like, grab me. I'm more than willing to help anyone that's like looking to potentially look at Chef. Definitely go through the learnchef.io. There's some good stuff there. It won't be immediately applicable, but you can start making like connections pretty easily. He asked, is it worth it to go to the trainings? I've never been to the trainings. I felt like I had a fairly good understanding of object-oriented programming. So when I looked at Ruby for the first time or Chef code, I already like knew Python, so it was pretty easy to transfer over. But even if you decided not to dig into like making your own LWRPs or anything, I feel like the native, like just the way you use the Chef resources is fairly easy enough that if you just read their documentation, you'd figure it out. Now, I'm not gonna like say don't go to the training because I'm sure it'll be awesome, but like if you're worried about like the cost, like give yourself a weekend with learnchef.io, play around with it, install it on your system, decide what you want to manage. I think you could probably figure it out. Cool. All right. We only have 2 minutes. It's starting to get red and angry. So, all right. Cool. All right. Thanks, guys.